Hey students, in this video I'm going to subtract these two expressions, and I'm going to do 3 examples if you want to fast forward or rewind to the one you want to look at. These two expressions right here, similar to addition, we want to have common denominators. So that's the first thing you want to understand, that when you add or subtract, you need to have common denominators. And if you look at the denominators right now, they're not at all the same. So you need to put the same factors in order to have the common denominators. So this factor needs this other factor, and we're going to go ahead and multiply x plus 1 on numerator and denominator. And then this other expression needs x plus 2. So we're going to put x plus 2, and we're multiplying x plus 2 times numerator and denominator. So let's go ahead and rewrite what we have next. We multiply 4 times x, and that's 4x. 4 times 2, that's positive 8. And then that gives you the factors of denominator, x plus 2, x plus 1, minus, multiply this in, and you get 2x plus 2 over the denominators of x plus 2 and x plus 1. So now that you have common denominators, you're going to focus on the numerators, and you're going to subtract these numerators. Now, the thing you need to remember here is that when you're subtracting each part. So it's easier if you put parentheses around this and distribute the negative in. So you can understand that you actually have negative 2x minus 2 for that part. And then you're combining it with 4x plus 8. So all of that is over the factors x plus 2 and x plus 1. Next, we simplify. So we simplify by looking at the common denominators, common terms, combine like terms. So 4x minus 2x gives you 4 minus 2, which is 2. And then 8 minus 2 gives you 6. So we end up with 2x plus 6 over x plus 2 and x plus 1. Now this could be the answer if it doesn't simplify anymore, but we do notice that this has a 2 as a GCF, so we're going to go ahead and simplify that. And it ends up in these two factors of 2 times x plus 3 over x plus 2 and x plus 1. So these are the factors. This is the factored form. If we want this in a simplified form or standard form, we multiply them. So 2 times x and 2 times 3 gives you what you had, which is 2x plus 6. And this binomial of x plus 2 and x plus 1, we do need to multiply. X times x is x squared, x times 2 is 2x, x times 1 is 1x, 1 times 2 is positive 2. These are like terms, and they combine, and you end up with x squared plus 3x plus 2. So this will be the standard form. All right, let's try another problem. Here's another problem, and similar to what we just did, your first thing to do is have common denominators. In order to add or subtract, you need common denominators. Now, in order to have common denominators, you need to have the same factors. So we need to first look at these and factor. So we end up with this factor being 3 times x minus 4, because you notice that they have a GCF of 3. And this denominator being two binomials that we need to find with the x. So a times c and b, that is 1 times negative 20, so that's negative 20, and then the b value is positive 1. Two numbers that you multiply to get 20 is 1 and 20, 2 times 10, and 4 times 5, and 4 and 5 is the one that will give you that 1 difference if we subtract. 4 minus 5 is positive 1, so we're going to do, 4 minus 5 is negative 1. So you want to have positive 5 and negative 4. 5 minus 4 is positive 1. So your factors here will be x minus 4 and x plus 5. The numerators stay the same. And now that we have the factors, we compare. So x minus 4 is the same factor, but the others are not there. So you need to, on this side, put this factor, x plus 5, on both top and bottom, numerator and denominator. And then on this side, we need 3. So this is what we have. So to rewrite this, we're going to multiply these two binomials with each other. And we're going to get x plus 5, x minus 2. X times x is x squared. X times 5 is 5x. X times negative 2 is negative 2x. And negative 2 times 5 is negative 10. If you combine like terms, you're going to end up with x squared plus 3x minus 10 over these factors of 3 times x minus 4 times x plus 5. And you're going to subtract these multiplications right here of 3x times 3, that's 9x, and negative 5 times 3, that's negative 15, over the factors of 3, x minus 4, x plus 5. So I changed the order, but all the factors are the same. We rearranged the factors, that's all. All right, next you notice that they're common denominators, so you're going to combine the numerators. Now keep in mind that this is a subtraction, so you have to understand you're subtracting each one of these from what you have. So put those parentheses and distribute that negative. Negative times 9 is negative 9x. Negative times negative 15 is positive 15. So that takes care of that. And then just bring down the x squared plus 3x minus 10. And all of that is together over 3 times x minus 4 times x plus 5. So here we simplify by combining like terms. Notice that there's no other x squared, so I'm just going to write x squared. There is an x and another x, so 3x minus 9x, that's negative 6x. And then negative 10 plus 15, that gives you positive 5. This is over the factors of 3 times x minus 4 times x plus 5. So now we're going to look at the numerator and see if this numerator could be rewritten as factors. Let's do the x for that. We're going to have a times c and b. A times c is 5. B value is negative 6. So what are the factors of 5? 1 and 5. And how can we get negative 6? Negative 1 and negative 5 combined can give you negative 6. So these two are the new numerator, x minus 1, x minus 5, over 3 times x minus 4 times x plus 5. Okay, and then just to double check for you to know if you're on the right track, we can do photomath. And I'm going to do that for you. Let me first find the page. All right, so photomath has it in standard form. That means that the numerator that we had up here is the correct numerator. And then for the denominator, we will just need to multiply these two binomials using the box method or the loops, and then times 3. And it should give you that answer right there. So again, you just multiply the binomials of x minus 4 and x plus 5, and you'll get a trinomial that you multiply times 3. So because of time, I'm just going to move on to the last problem. Here we have this other subtraction problem, and on this one, we are, again, wanting common denominators. These denominators are not common at all, so we need to turn them into factors. This trinomial becomes two binomials, so we're going to do the x, and the a times c and b for that trinomial is 10 and 7. So the factors of 10 that will give you 7 are 5 times 2, positive 5, positive 2 will give you positive 7. So that's x plus 5, x plus 2. So those are the factors. Notice that now we notice that x plus 2 is already there. So we just need x plus 5 on this fraction. So x plus 5 on denominator and numerator. The left side we didn't change at all, so we're just going to rewrite it x plus 1 over x plus 5 times x plus 2 minus, and then this distributes, and we're going to have 8x plus 40, x plus 5 times x plus 2. And then after the denominators are the same, we're going to combine numerators. Keeping in mind that this is going to be in parentheses and the negative distributes. So negative times 8 is negative 8x. Negative times 40 is negative 40. And then let's bring down the other. So x plus 1 over x plus 5 times x plus 2. Then you combine like terms, so you have x minus 8x, so that's negative 7x. And then you have 1 minus 40, that's negative 39, over x plus 5 times x plus 2. So for this one, you want to check if there's a GCF, and there's not. So let's check what Photomath has to say about this one. Let me find that paper. Okay, so Photomath has this as an answer, which is just saying that you're going to move a negative that they both have. You're going to take it out, and then they're going to both become positive. So that's how this becomes positive. And then the negative that you took out technically goes right here because it's a negative answer. And then of these multiplications of these binomials will give you this trinomial. So there's different types of ways to get this answer. I'm just trying to show you how to get there. All right, hopefully this video helps you with subtraction.